Hello and welcome to this LNG Industry Spotlight. Today I am joined by Dennis Long, Director of Global Marketing, Energy and Environmental Technologies for Watlow. Dennis has worked at Watlow for 38 years and his main responsibilities include global business development and product recommendations, especially in emerging markets and technologies, as well as strategies to support the development. In this session, we will be reviewing some of the topics raised in Watlow's recent article entitled Turning LNG the Colour Green. This article investigates the pressures to electrify process heating and the role played by electric heat exchangers. Dennis, thank you for joining us. It's great to have you with us. I look forward to hearing some of your thoughts on the questions we have lined up for you. So let's begin with something of a broader question. Decarbonisation is a buzzword that is frequently written in corporate strategies and said by policymakers. So for those who don't know, can you detail how this actually factors into the LNG industry and how electrifying process heating can assist with industry decarbonisation?
Yes, so decarbonisation has to do with anything that releases basically a carbon type molecule into the atmosphere. So whether that's carbon dioxide or whether it's methane, anything that you can do to reduce those emissions into the atmosphere is a way to decarbonize a process. So one way that we do that with electric process heaters is by connecting to low carbon sources like renewable energy.
Considering the available heat exchanger designs, how does continuous helical flow technology differ?
So the traditional heat exchanger technologies are things like segmental baffles, axial flow. There's also a quadrant type helical spiral baffle heat exchanger. There's a technology called rod baffle. None of those have a continuous helical flow path. So in the Helimax, from a geometry perspective, it's a helicoid. And so the flow goes through a geometric shape known as a helicoid, and it's continuous. So the continuous part of that is one of the huge advancements in the heat exchanger industry, because no one has a flow process that doesn't have a sudden change in the flow path as it goes through the heat exchanger.
The problem of fouling is often discussed with regards to heat exchangers. How can new technology improve heat exchanger performance and counteract fouling?
So fouling is a function of temperature, and it's a function of flow velocity and shear stresses from the fluids. So anything you can do with the heat exchanger design to improve the velocities, to reduce the skin or tube temperature, are things that can reduce the fouling rate inside of a heat exchanger. So the fact that the Helimax has a continuous flow path is one way that we don't end up with what we call dead zones or eddy current zones or low flow zones inside of the heat exchanger. And that assures that we maintain the velocity that we're after inside the heat exchanger, which is part of the equation for fouling rates.
By switching from gas-fired heaters to electric heat exchangers, what challenges may be experienced?
So the main difference with a gas-fired heat exchanger is they do have the availability to flow the fluid on either what's called the tube side of the heat exchanger or the shell side of the heat exchanger. With an electric heat exchanger, the heat source will always be inside of the tube and the heat exchanger, so all flow will take place on the shell side of the heat exchanger. So other than that, there's nothing else that you can't do with an electric heat exchanger that can currently be done with a non-electric heat exchanger.
That's really good. Hypothetically speaking, climate change has been eradicated and carbon footprints are non-existent. Would it still be important to seek electrification of LNG key facilities?
So So we could get in a situation where we hypothetically were in the types of atmospheric conditions we were in the mid 1800s. And so if we got there and we got back into the same processes that we have today, we're going to end up with atmospheric conditions that are similar to what we have again today. So the bottom line is it's going to be important to use technologies that produce lower carbon footprints in order to maintain the climate in the situation that's desirable.
How quickly can improvements be seen when using these heat exchangers?
Well, it depends on the source that they're connected to. So each source has a different level of carbon footprint. So if we're talking about carbon dioxide, the amount of the tons of carbon dioxide that a process emits into the atmosphere. So if you were connected to, say, a source that emits a very high amount of carbon dioxide, and now you connect the electrical process heater to a renewable energy source with zero emission of greenhouse gases, then that very quickly makes a huge difference in the situation compared to what it was previously. So it's situational. Everything has a different carbon footprint. Scientists know very well, it's very well studied. They know where the biggest sources of greenhouse gases are coming from, and they know what the biggest targets are that we need to change in order to change the situation quickly.
Can you detail a successful application of Watlow's technology?
Oh, we have many installations in LNG facilities, for example. One easy application that everyone will understand quickly would be something like a mole sieve desiccant dryer, which is routinely used in the LNG industry to remove moisture from the gas stream. And that is simply a mole sieve that is something that absorbs water vapor from the gas source. And so a great example there is electric process heat is used to thermally regenerate the mole sieve bed. And so that can be done with either a gas-fired source or an electric source, for example. So that's one example of an installation in LNG.
Looking to the future, with more focus placed on the climate and targets needing to be met, do you envisage an increase in customers using the more environmentally friendly heat exchangers?
Well, the electrification initiative is strong. Our customers, I'm on the phone, many customers per week right now, and the amount of electrification projects they have going on is on the upswing. And so we are seeing a lot of requests to solve thermal applications that have previously been done with non-electric sources, whether it's gas-fired or what it is. So there's a definite increase in companies that are looking to electrify their process heat. And right now, a lot of those companies are performing studies. And so I think the rate of electrification is going to ramp between here and 2030. So I think we're in a situation where we're going to prove out electric process heat more than it has been done historically.
Are there also solutions available when it comes to high megawatt thermal systems?
Yeah, so that's a question around what we call the duty rating or the nameplate rating on the heat exchangers. And traditionally, customers have employed, and the industry has employed, electric heat exchangers in smaller nameplate ratings. And I say small, I mean 2 megawatts or less. Well, now we are seeing solutions up to 200 megawatt requests that we have successfully developed solutions for in electric. So when you get to that size, 200 megawatts, that covers just about anything in the industry. The industry, depending on whether it's refinery or the LNG industry, what it is, typically needs solutions in the 10 to 30 megawatt range is kind of the sweet spot of what size is needed.
Where do you envisage the future opportunities for Watlow will be in the energy market regarding digital transformation and Industry 4.0?
So I think there's a great opportunity as you go up in size on these electric systems. And again, we talked earlier about a lot of these have been 2 megawatts or less. As you go up in size, the equipment criticality becomes higher as well. And so there's a need on the electric systems to have Industry 4.0 type of control systems that inform the customer of the heater and the thermal system health, to give them a heads up for predictive maintenance, to be able to perform analyzation on the process itself. Those kind of things are all digitalization opportunities as well as Industry 4.0 opportunities. And so we're starting to see those come from the market as well. And we'll have solutions that meet the needs for customers going forward in that arena as well.
Thank you, Dennis. That's great. Unfortunately, that's all we have time for today. So a special thank you for joining us and exploring the world of electric heat exchangers. Just before we wrap things up, I would like to remind everyone that Watlow's article, Turning LNG the Colour Green, is found in the July issue of LNG Industry, which can be found by accessing lngindustry.com/magazine. Thank you, Dennis. It's been lovely to talk to you. You're very knowledgeable about everything.
Thank you. Thank you. Have a great day.
Have a great day too. Thank you very much.